Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 6, Section 1, Chapter 2, Topic 7. Continuous Improvement and Innovation in Semiconductor Manufacturing. In the dynamic landscape of semiconductor manufacturing, quality and reliability are paramount. However, these concepts are not static. They require continuous improvement and innovation to keep pace with evolving technology and meet the ever-growing demands of customers. Semiconductor manufacturers recognize the critical importance of staying ahead of the curve in terms of product quality, reliability, and performance. This necessitates ongoing investments in research and development, advanced materials, and state-of-the-art manufacturing processes to enhance the overall quality and reliability of semiconductor products. Continuous improvement is ingrained in the culture of semiconductor manufacturing companies. It involves the systematic process of identifying areas for enhancement, implementing changes, and measuring the impact to drive incremental improvements over time. This approach fosters a culture of excellence and encourages employees at all levels to contribute to the ongoing refinement of products and processes. Continuous improvement initiatives encompass various aspects of semiconductor manufacturing, including product design, material selection, manufacturing processes, testing methodologies, and quality assurance practices. Innovation is another key driver of quality and reliability in semiconductor manufacturing. Innovation involves the introduction of new ideas, technologies, and methodologies that push the boundaries of what is possible in terms of product performance, functionality, and reliability. Semiconductor manufacturers invest heavily in research and development to fuel innovation and stay at the forefront of technological advancements. This includes exploring emerging technologies, conducting fundamental research, collaborating with industry partners, and leveraging the expertise of interdisciplinary teams to drive innovation across the organization. Research and development, R&D, play a central role in driving continuous improvement and innovation in semiconductor manufacturing. R&D activities focus on exploring new materials, processes, and technologies that have the potential to enhance product quality, reliability, and performance. This includes researching advanced materials with superior electrical, thermal, and mechanical properties, developing innovative manufacturing processes that improve efficiency and yield, and exploring novel packaging techniques that enhance product reliability and durability. Advanced materials are fundamental to achieving higher levels of quality and reliability in semiconductor manufacturing. Semiconductor manufacturers are constantly exploring new materials with properties that meet the stringent requirements of modern electronic devices. This includes materials with high thermal conductivity for improved heat dissipation, low dielectric constants for reduced signal loss, and high mechanical strength for enhanced durability. By incorporating advanced materials into semiconductor packaging and assembly processes, manufacturers can improve product performance, reliability, and longevity. State-of-the-art manufacturing processes are essential for achieving consistent quality and reliability in semiconductor products. Semiconductor manufacturers leverage advanced manufacturing technologies, such as precision lithography, thin film deposition, etching, and wafer bonding, to produce semiconductor devices with exceptional precision and accuracy. Additionally, process control systems monitor key parameters throughout the manufacturing process to ensure adherence to specifications and minimize variations that could impact product quality and reliability. Quality assurance is a critical aspect of semiconductor manufacturing that ensures the products meet the highest standards of quality and reliability. Quality assurance practices encompass rigorous testing, inspection, and validation procedures to identify defects, weaknesses, and vulnerabilities in semiconductor products. This includes reliability testing under simulated operating conditions, thorough inspection of incoming materials and components, and statistical process control to monitor manufacturing processes and detect deviations from expected performance. In conclusion, continuous improvement and innovation are essential pillars of quality and reliability in semiconductor manufacturing. By investing in research and development, advanced materials, and state-of-the-art manufacturing processes, semiconductor manufacturers can enhance the quality and reliability of their products and stay ahead of the competition in today's fast-paced and demanding market. Through a relentless commitment to excellence and innovation, semiconductor manufacturers can meet the evolving needs of customers and drive progress in the semiconductor industry. Thanks for watching. Please like, share, and subscribe.